السلام عليكم ورحمة الله وبركاته. بسم الله الرحمن الرحيم. إن شاء الله today we'll try to finish the first order logic session. Inshallah, hopefully, if we do that, then with the next lecture we will start a completely new session, new topic about probabilistic inference or probabilistic reasoning, inshallah. What is remaining from the first order logic session and the logical agents session as a whole is two things. One that is quick that we will cover inshallah in this slide about the interaction with the knowledge base that is represented by first order logic, and then how we do inference in first order logic. So how do we interact with knowledge bases? We discussed that before, but there is something that is more specific to first order logic that we will discuss now. Before, we said that we have two ways of interaction with the knowledge base. The first one is the sentence tell. Okay, the sentence tell adds one sentence to the knowledge base. Okay, so if the agent here, we assume that we are in the one-pass world, if the agent perceived smell, breeze, and no glitter at time 5, then the tell statement will add that to the knowledge base. The other one is the ask statement, which is querying the knowledge base. We used to have a query that is a proposition before, but here the query is a quantified sentence because we are talking about first order logic now. So this is the sentence that is in front of us now is asking the knowledge base if there exists a best action of at time 5. Okay, so A here is a variable, and this is an existential quantified statement, which means does the knowledge base entail some best action at t equals 5, at time 5? Is there any best action at time 5? Okay, now we used to have the answer to be from the knowledge base to be yes or no if I can entail that sentence. Okay, now imagine that the knowledge base will just say yes, there is a best action at time 5. Would that be really useful? Maybe, but not what we expect. It's like the example in the textbook. I liked it really. When you ask someone, what is the time? Can you tell me the time now? And he says, yes, I can tell you the time. Okay, that's not what you meant, right? That's not what you want. You want really to know the time. So the actual intention here is what is the best action to do, not whether there is a best action or not. So saying yes here will not be sufficient, will not be that useful. It might be useful, but it's not what we really need. What we really need is to find the best action, is to find the value, more formally, is to find a value for that variable that will satisfy this sentence. We call this substitution. When we try to find a value, okay, that for the variables in a sentence, we call that substitution. So one possible answer that we can get from the knowledge base in this case is to substitute A. So yes, there is a best action, and the best action is when you substitute A with shoot. Okay, we call this a substitution or binding list. So here you will get values for the variables, okay, that will if you substitute it in the query, then the knowledge base entails that sentence. Okay, so now we can say that the knowledge base entails the sentence that the best action at time 5 is shoot. Okay, so that's the difference between querying the knowledge base in propositional logic and querying the knowledge base in first order logic, because in first order logic we have quantified statements. It won't be just sufficient to say that yes, this sentence can be satisfied, but what we really need is how. Okay, and how is done by the substitution. So let's generalize this concept. given a sentence S and a substitution sigma, S sub sigma denotes the result of plugging or applying sigma into S. Okay, so if I have a sentence like that, smarter xy, which means x is smarter than y, then one substitution will be x with Hillary and y with Bill. So now if we plug this substitution into S or apply this substitution to S, we will get S sub sigma, which is smarter Hillary Bill, which means Hillary is smarter than Bill. Now S is not equivalent to S sub sigma. Okay, because S is more general. S sub sigma is specific one. Okay, it says that specific person is smarter than another one. Okay, but we got it from applying a specific substitution to the original sentence. So the concept of substitution is really important, and we will use it a lot today in this lecture, inshallah, and in inference in first order logic. Now we can say that asking the knowledge base about a sentence will not just return true or false, it will not return just a Boolean value, but it will return some or all substitutions such that the knowledge base entails the specific sentence after applying this substitution. Okay. So remember that S is the queried sentence. So the ask statement will return the substitutions that we can do to S, or we can apply to S, so that the knowledge base will entail that sentence after substitution. Any question about this? Is that clear? No questions? Okay, then we are done with this part, and let's switch to the last part of this session, which is about inference. Okay, I think you see now the slides. Okay, fine. The last part will be inshallah about inference in first order logic. To do that, we'll start with two general rules about quantified statements. The first one is the universal instantiation rule, and the second one is the existential instantiation rule. In universal instantiation rule, we have a universal quantified sentence like this for all V alpha. Now, this sentence is true. If this is in a knowledge base, then we assume that this sentence is true for every value of V, right? So that means that with substituting V with any value, that will be true, which means that we can entail alpha with applying any substitution of V with any value G in the domain of V. Okay, so we have a universally quantified statement. It should be true for every value in the domain. So if we substitute the variable with a specific value, then we can entail it from the knowledge base. Example: for all x, king x and greedy x implies evil x, which means if x is a king and greedy, then x will be evil. Now we can apply universal instantiation from that to that sentence, which means I will instantiate it with specific value of x. I can use any possible value of x, right? So I can say King John and greedy John implies evil John, or King Richard and greedy Richard implies evil Richard, or King Ahmed and greedy Ahmed implies evil Ahmed, if Ahmed is within the domain of x here. Okay, so I can instantiate it so many times with every possible value of x. When we say with every possible value, that means that we'll do substitution, right? So if we do that substitution to based on the values of v to alpha, then we can entail alpha with that substitution. And as I said, the universal instantiation can be applied several times to add new sentences. And this sentence is different from that sentence, right? And this sentence is general. Now we instantiate it with John. Now we can instantiate also with Richard, and we can instantiate it with every value possible of x. The other one is existential instantiation. So here we don't have for all, we have there exist. Okay, so which means that there is at least one value of v that will satisfy alpha. Now we can substitute v with specific value k in alpha, and now the knowledge base entails that entails alpha with that substitution. Okay, so that notation here, substitute v with k in alpha, this is like saying alpha with this substitution, v with k. Okay, right. What is the difference between this one and the previous one? They look very similar. They look very similar. The only difference is that there we had for all, and here we have there exist. Okay, what is the actual difference in the application? The actual difference is that in the previous one, we can instantiate it so many times. Here we can instantiate it just once, because it is guaranteed that at least one is satisfied. So we can only apply it just once. Let's see an example. Let's say that we have this sentence: there exists x, crown x, and on head x John, which means that there is x is a crown and x is on the head of John. Now I can instantiate it just once with specific value of x. I used C1 here. So now I can entail, well, what do we mean by instantiate here? Entail. Okay, so from the previous one, we can entail so many sentences based on the possible values of x, or v was in the previous slide, or x in the example. Here we can instantiate it just once. So we can say crown C1 and on head C1 and John, where C1 is a new constant symbol. One very important thing is that the symbol that we use does not appear elsewhere in the knowledge base, because we don't know which one satisfies actually this sentence, but we can give it a name, which is K here and C1 here. So this symbol must be different from anything in the knowledge base. Okay, it should not appear elsewhere in the knowledge base, and this symbol is called Skolem constant. Yes, Faisal. It's not a variable, it's a constant. That's a big difference. It is a constant. No, here this sentence, okay, is existential. Yani I say there exists some value. I don't know what is that value that satisfies this. Now I say the value that satisfies this is C1. We don't know yet, but we might unify it with some. Yani we might find that C1 equals something in the knowledge base, or I mean later. Yani we might imply that it is equal to something else. Okay, that depends on what is in the knowledge base. But now it is it's a constant. It will remain a constant anyway. And remember, a constant refers to an object in the first order logic knowledge bases. Okay. You're welcome. Any other questions? Okay, so the last sentence here just says that, as I said it, I think before, that existential instantiation can be applied just once to replace the existential sentence. Okay, we cannot apply it more than once because it is not guaranteed to be satisfied for more than one value. Okay, is that clear? Okay, now we will talk now about inference, and um, in this session we will cover two ways of doing inference in first order logic. The first one is to convert the first order logic into propositional logic and apply the algorithms that we studied before. Or the second one is to use a specific algorithm for the first order logic. So the first way is to reduce the knowledge base into propositional logic. Okay, how can we do that? Suppose that the knowledge base contains these sentences. Okay, now this specific sentence, which is the first one, is a universally quantified sentence. Okay, now from the universal instantiation rule, I can entail from that sentence every sentence that replaces X with any possible value. So I can say King John and Greedy John implies Evil John, and also I can say King Richard and Greedy Richard implies Evil Richard. Okay, so these two sentences are instantiated from that one. Okay, so now we can replace, it's kind of replacing this sentence with these two sentences. Now look at the entire knowledge base now. It has no quantified statement, no quantification at all. So this is very similar to propositional logic, only if I consider all the predicates to be propositions. So if I consider this is a proposition, and this is a proposition, and this is a third proposition, and that's a fourth proposition, and so on. So if I made all propositions here, all predicates here propositions, then this will look like propositional logic. So I can give this even names like P1, and this is P2. Okay. Once we do the instantiation for all sentences in the knowledge base, then we can get rid of the unified sentences and deal with sentences that have no quantifiers, which means that with considering the predicates to be proposition or propositional symbols, we converted the knowledge base into propositional logic, or we can say that the new knowledge base is propositionalized. So this process is called propositionalization, the act or the process of converting the knowledge base from first order logic to propositional logic, called propositionalization. Okay, type. What is the benefit of doing propositionalization? I think it's clear. If we converted the knowledge base into propositional logic, then we can apply any of the algorithms that we discussed earlier, like model checking or resolution or any other algorithms that we didn't even cover. Okay, because now it is propositional logic. We don't need first order logic. Khalas, we get rid of everything that that is connected to first order logic, and we can deal with the new knowledge base as if it is actually represented by propositional logic. Right. What is the problem with that? The problem is that we might generate lots of irrelevant sentences. So if we do this propositionalization, we will also need to propositionalize the query convert the query into propositional logic. We apply any of the inference algorithm like resolution, we get the result, right? So we can do that with every query. But this, as I said, will generate lots of irrelevant sentences. Let's see an example. If I have this knowledge base, and look at this knowledge base, and let's say that, so this is again the sentence for all x, king x and greedy x implies evil x. We also know that John is a king. We know that everyone is greedy, and we know that Richard is the brother of John. Now, if I asked the knowledge base about this sentence, evil John. So whether we can entail from this knowledge base that John is evil or not. Okay? Of course, to us, it is obvious, because everyone, this rule is applied to everyone, right? So if someone is a king and greedy, then he is evil. We know that John is a king, so this is satisfied, and we know that everyone is greedy, so this is also satisfied for John, which means that John is evil, right? But what will happen in if we do the propositionalization is that we will instantiate this with every possible value. We will instantiate that with every possible value. So we will get something like Richard is greedy, although that we didn't actually need this at all in to know whether the knowledge base can entail that John is evil or not. So knowing that Richard is greedy is useless for us. Of course, this is just one example. In bigger knowledge bases and other queries, we might actually generate so many things that are not relevant to the query at all. Okay, so that's not an efficient method. That's not an efficient method. Any questions? I heard someone has raised hand, I think. Faisal? Okay, but if we keep it, then we have to deal with the quantified sentence. Well, that's the problem. The idea here is that we need to get rid of the quantification because we don't know how to deal with it given the algorithms that we studied before. Okay, so we'll have to remove it, and we have to, in order to remove it, we have to replace it with every possible value, and that's not efficient. Okay, the idea that you just mentioned, which is let's keep it but only instantiated when we need to do that, this is actually the core beyond the second idea that we will inshallah just study now. Okay, any other questions? Okay, now, so this method, we said that it's not efficient. So propositionalization is not efficient because it will generate so many things that we might not need. Now let's switch to the second method, which will use a core idea called unification. So what is unification? We have two sentences. Like these two sentences, King X and King John. And we want to find a substitution of the variables in these two sentences so that these two sentences with that substitution will look identical. This is called unification. Okay, so again, we have two sentences. We want to find substitutions that will make these two sentences identical. So what is the substitution that I can do to these two sentences to make them identical? Of course, it is very clear. If we substitute X with John, these two sentences will be identical. So we call this, in this case, that these two sentences are unified using the substitution of X with John. Okay, and this is the concept of unification. So again, unification is about finding substitutions that make different logical expressions, this means sentences, look identical, unifying them, in other words, okay? Unifying them. Find how we can do a substitution that will make them the same, will make them identical. Same here, if I look at greedy x, at greedy y, and greedy John, of course, substituting y with John will make these two sentences identical. So now if I have these two sentences, this is the first one, and I have these two sentences, I can say that this substitution will make them identical. So substitute x with John and also substitute y with John will make these two sentences identical, which means these two sentences are unified. Let's see how let's see examples of unification, but let me show you first the formal way of showing unification. So when we say unify alpha and beta, this is a process that will result into a substitution that will make alpha and beta unified. Okay, so unify alpha and beta is theta. Theta is a substitution. If alpha sub theta, which means applying theta to alpha, is equal to beta sub theta, which means applying theta to beta. So what is alpha and beta here? Alpha, this is beta, and this is theta. Okay, so keep in mind this process. We have two sentences. Of course, they might not be unified, but unifying them means that we need to find the substitution that will make them identical. So let's take examples. Let's see the first pair here. Knows John X and knows John Jane. Can we unify them? And if yes, what is the substitution that will unify them? Any answer? Faisal? Yes, X with Jane. Jane or John? Faisal, Jane or John? Jane. Yes, exactly. Okay, so this substitution now will make these two sentences identical. Okay, so that's the unification. Thanks, Faisal. How about the second pair? Knows John X and knows Y O J. Yusuf? Wa alaikum assalam wa rahmatullahi wa barakatuh. Yes, Y with John and X with OG. Thank you, Yusuf. How about the third one? Anyone? Abdurrahman, where are you? والله أنا عارف إن أنت you are here بس يعني can you answer this one? Okay, that's not useful. Okay, so give me the substitution, Abdurrahman. Okay, say it again. So what is the substitution? So they can be unified first, right? Okay, and what is John? Okay. Mother of Y or mother of mother of John? Yes, because Y is substituted with John here, right? Yes. Okay, thanks, Abdurrahman. Okay, how about the last one? How about the last one? Anyone? Type someone other than Faisal, someone who didn't appear yet. Maheen. Maheen, are you with us? Maheen? I don't hear you. It looks like you are using the mic, but I don't hear you. Okay, you are speaking, but I don't hear you. طيب Mahmoud. Thanks, Maheen. Mahmoud? Yes, I hear you. So, are these unified? You don't know, or they are not, or we cannot unify them? You don't know. طيب, why don't you know? What is the problem? Yani how can you check whether they can be unified or not? Try to find a substitution that will make them identical. So we have John here, and we have X here, right? So maybe we can substitute X with John, right? So that's the first part, right? Mahmoud? Okay, now the second part, here we have X and OJ. Can we substitute one variable with two values? No, we cannot, right? So that means that we cannot actually do the unification in this case, right? Because we cannot substitute one variable with two values. So these two sentences are not unified, cannot be unified. Okay? Fine. Thanks, Mahmoud. Is that clear, Mahmoud? Okay, thank you. Now, okay, so let me first clear the board here. So these are the values that we used. Now, if you look at these two sentences, what is the meaning of these two sentences? Yani, assuming that we usually in such sentences we have sorry, in these two sentences we usually have universal quantification because we have a variable here. Okay, so if we know that these two sentences are actually for all x, John knows x, and for all x, x knows OJ. Okay, so this one means John knows everybody, right? Because that's for all x, right? So knows John, John knows everybody. Okay, and this one means everyone is known by x. OJ is known by everybody. Okay, OJ is known by everybody. Here, John knows everybody. Here, everybody knows OJ. Right? Fine. Will it make any difference if I change this x to be y or z? And instead of x here, I made it z. Will it make any difference in the meaning of this sentence? No, because we didn't mean x in particular. We meant, because of the universal quantification, we meant everyone, anyone. So I can replace here, or I can substitute, or I can eliminate. That's better because substitution here has another meaning. I can eliminate x and use another variable z. If I do that, and that will not change anything in the meaning, in the knowledge base. If I do that, then of course I can unify these two sentences. Then the unification will be, or the substitution will be, Z with John, and X with OG. Okay, this what I did is called standardizing apart. Okay, that's a process that will eliminate the overlap of variables. So I can remove X here and use any variable that was not used before, Z17, Z35, W, anything that any variable that was not used before can be used instead of X here, just to avoid the overlap of the variables. The failure that happened here was because we used the same variable in two different quantified sentences, but actually we should not do that. Okay, that doesn't mean that failure always happens because of that. Two sentences might not be unified generally, okay, but the failure in this case happened because we use the same variable. Okay, any questions about unification? No questions? Everything is clear? Okay. Okay, good. Now let's move on to the inference, the basic inference rule, which is what we call generalized modus ponens. Okay, of course you are familiar with modus ponens before, right? What is modus ponens rule? It says that if I have an implication like that and I have the premise, then this can entail the conclusion. Okay, right? Type. If I have something like this, P1 and P2, and that's as a whole, implies Q. What do I need to entail Q here? I need to know P1, that P1 is 2, and also I need to know that P2 is 2, right? If that's the case, that's another. If that's the case, then I can entail Q, right? Okay, so now this is standard modus ponens. What do you mean by generalized modus ponens? If I have a sentence like that, then in order to entail Q, I need to have P1 to be true or known in the knowledge base, and P2 and Pn, right? So that's the standard modus ponens again in order to infer or entail Q. But what if these propositions here are quantified sentences? They are quantified sentences. Then this rule says that it is sufficient to unify it with another sentence that is in the knowledge base. So for example, P1 can be unified by P1 prime, and P2 can be unified with P2 prime, and Pn can be unified with Pn prime. If that's the case, if we have in the knowledge base sentences P1 prime, P2 prime, up to Pn prime, where every pair of the propositions here are unified, that means that there is something that we can satisfy for, or there is a way to satisfy every one of these premises. Of course, unification means that there is a substitution theta that will make these unifications. Then we can entail that Q is 2, but with applying the same substitution. So we can entail Q sub theta in this case. Not Q, Q sub theta, with the substitution that made these pairs unified. If it looks complex, let's see it in an example. Let's say that we have this knowledge base. That's the same knowledge base that we saw before. And we want to infer if, or we want to entail that John is evil. So that's what we want to entail here. Okay, now how can we apply generalized mod exponents in this knowledge base so that we can infer something about John is evil? Because that's the only thing that has evil here, right? So I need to activate this. How can I activate this? How can I apply mod exponents on this knowledge base? Right. I have this sentence, and it has these two premises. Okay. So I need to unify this with some sentence in the knowledge base, and unify this with some sentence in the knowledge base. If that's the case, then the substitution that I will do to unify these two sentences, I can apply to the conclusion, and thus I can entail the conclusion with this substitution. So if I can find King John and greedy John, then I can entail evil John. Let's see if we have this in the knowledge base. So P1 here, if we want to apply the generalized mod exponents, P1 here is king of X. Right? Right. What is P1 prime? P1 prime is another sentence in the knowledge base that can be unified with this sentence. Where is that sentence that can be unified with king of X? Of course, this is this one, King John. So P1 prime is King John. How can we unify them? What is the substitution? The substitution is substitute X with John. Right. The second premise here, P2, is greedy X. Right? Type. Greedy X. Can we unify it with something from the knowledge base? Do we have greedy something? Yes, we have. We have greedy Y. Right? So we can say that P2 prime is greedy Y, which means X is substituted with Y. Sorry, with Y. So X and Y have the same value. Type. That means, this by itself means, because we already substitute X with John, right? So that means that we will substitute Y with John. So we can actually say substitute Y with John. That means that these two premises now, P1 and P2, are satisfied with this substitution. So we can entail evil. So what's the Q here? The Q here is evil of X, which means, so now Q sub theta, if this is theta, Q sub theta is evil, applying this substitution to evil of X, that will be evil of John. There is not, yes, John. Okay, is it clear how we applied the generalized mod exponents to this knowledge base so that we can entail evil John? So we use the unification. We have to use unification here. Okay, so unification is kind of matching. I want to match the the quantified predicates or quantified sentences with something that is known already. Okay, this kind of matching is called unification. If we can unify every premise, then the overall substitution can be applied to the conclusion, and thus we can entail the conclusion with applying this substitution. Okay, so let me ask you if you have any question first before we move on. Any questions on this? Is it clear? Okay, good. So let me erase all here, and so this is exactly what we did. Okay. Now, applying the generalized mod exponents require that the knowledge base will be of definite clauses. We heard this terminology before, right? When we talked about the resolution algorithm. Definite clauses are the clauses that have exactly one positive returns, and we said that this is equivalent to the implication statements when we have positive, when we have all positive returns. Okay, so we have here king x, greedy x, evil x. So this is a definite clause. Okay, this is a definite clause because if you remember, it can be converted into a disjunction of literals where only one is positive. Okay, so that's the condition. Of course, something like that also is a definite clause by definition. And all variables will be assumed to be universally quantified. Okay, so if we have something like this, so we can, that means that we can even omit the quantification, assuming that all of the quantification will be universal quantification. If there is existential quantification, we can instantiate it. Right? We can just say that we instantiate it just once and we replace it with an instantiation and we move on. Okay, so I think we ran out of time. Unfortunately, we didn't finish yet this session. There is, I think, few slides talking about the algorithm now that we can use for inference, which will use kind of forward chaining that we used before, but using the generalized mod exponents rule. Questions, Abdurrahman? Yes, project 1 grading is okay. So let me answer this before the other question. Project 1 grading is about to finish. I think during this week you will get the grade, inshallah. Okay. Yes. I don't think at that moment. I don't think the time is really tight with, especially with this, with the 1 week extension of the exam period. I don't think there will be time for another project. Okay. Okay. Well. Any other questions? Okay, so we'll stop here, inshallah, and talk to you on Tuesday. We'll continue with inference, probably for maybe the first 15 minutes, and then we'll start with a completely new session that has nothing to do with what we did before, which is about probabilistic reasoning. So talk to you, inshallah, on Tuesday. Assalamu alaikum.